Okay, in this video I'm just going to quickly go over how to evaluate somewhat simple limits, not completely simple ones, but I'm just going to start off by kind of showing you, we already know that a limit is the value that x, or well, in most cases x, is approaching from the left and the right. If the left one equals the right one, then that means the limit exists. If not, then the left one only exists, or the right one only exists, or whatever. So, in this one, I'm just going to show you some simple ones. So, a lot of times, you're just going to be able to, or I guess not a lot of times, but the simplest one will be just plugging in the value. So, for example, in this one, we just want to know what the limit's going to be when x goes to -2. Now, there isn't an asymptote or anything at -2, therefore, you should be able to just plug it in, and that would be -2 plus -2 squared plus 1, which is the same thing as -2/5. That was not a 2. Wait, let me try it again. -2/5. Alright. um, so, the first thing you want to do is just check, can I just plug this in without causing any problems? Now, the only thing that might end up happening in this case would be, what if you get a value that would cause something to, I don't know, divide by 0. So in this question, you're going to have a case where you're going to have to do a couple more steps, and later there's L'Hopital's rule that is when you can do derivatives, but in this part of the year we haven't gotten to that yet. So for a problem like this, well, if you plug in 1, then you're just going to get 1 over 0, and that obviously can't happen. So you're going to have to see what is going to happen by plugging in a few values. Now, in this one, you can't plug in 1, because you plug in 1, you're going to get something that divides by 0. So instead, you got to plug in things from the left and the right to see if this limit exists. So if we plug in something really, really close to 1, but a little less than 1, you can get a somewhat, I don't know, like a guess. So in this case, it'd be x. We'll do like 0.9. And you'll get 1 over 0.9 minus 1, which is the same thing as 1 over -0.1, which is going to be a bigger number in the negative direction, so it's going to actually be a bigger negative number. And as you keep getting closer and closer, you're going to be dividing by small. We're closer and closer, I mean like you're going to be getting 0.999 or 0.99999. You'll be getting numbers like -0.000009, which are just going to become bigger negative numbers. So you can say that this equals negative infinity. Once again, just kind of an approximation. This would actually not equal negative infinity. It would be 1 from the left. But my point is that you're going to get, it's just going to get bigger. As you get closer to 1 from the left side, they're going to get bigger in the negative direction. Now let's plug in like 1.1 of this. Then you would just get 1 over 0.1, which as you get closer and closer to 1, we're doing 0.01 and then 0.001 and so on and so forth, you would just get bigger numbers, and that's going to eventually equal infinity. So if we checked from the left and you got things are getting more negative, and you got things from right, they're going more and more positive, then that means you're getting something like this. And as we know from before, limits do not exist in a graph like this at that point. So the answer of this one would simply just be D does not exist, or DNE. All you had to do is just plug in a few values to see what the trend of the graph was looking like. And then a lot of times you're going to have to do things where you're reducing. So in this one, I barely remember how to do this. I'm kind of just looking at my notes right now. But you can get things that are like this, which would be, x cubed minus 27 over x minus 3. Now you look at this first and go, well, you're going to divide by 0 if you just plug this in. But actually, can you even see that? You're going to, get a divide by 0 if you just plug 3 in. But if you then look at the top part and go, well, I can actually factor this. It's not fun. But using some pre-calc knowledge I don't remember, and I probably should look up before the AP test, you can factor out this x cubed minus 27. So I'm just gonna rewrite this as the factored version, which once once again recommend you look up, just because it's something you probably should know how to do, and you'll get something that looks like this over x minus 3. And as you see now, you can actually cross these out, and you can just then do 3, plug in the values. So you get 3 squared plus 3 times 3 plus 9, which is going to be 27. Right? 27? Yes, 27. The last one I want to do very, very quickly is, oh, and then also I should mention that sometimes you just have to picture the graph in your head and think, does this even exist on the left or the right? So for this one, I'll make this negative 3. Only 2 more examples I'm going to do, and this would be x plus 3. Well, you're going to get 0 if you plug that in, but if you think about it, the graph of this looks something like, if this is negative 3, it looks something like this. So from the right side, it's going to equal 0, which is what you would get if you did square root of 0 by plugging in with negative 3, but from the right side, it doesn't exist. And for that reason, you have to say that this actually does not exist, and that's just basically because of the graph. Alright, and then the last one I'm going to do really quickly is for a problem with this really annoying thing that is a greatest integer function. That is a greatest integer function, if you don't know, is basically whatever value is going in for x, it's going to just jump down to the greatest integer of it. So this is that one that looks like that, and it kind of looks like some stairs. That's what the greatest integer function is. So if you look at this graph, when x equals 0, well, as you put in 0.5, the greatest integer of that is just 0, so it's just going to keep going, and then this would be 1, 2, 3. Now why am I showing you this? Because for a problem like this, it would just keep going down like that, and for this reason, this one does not exist, because from the right, it is approaching 0, or from the left, it's approaching negative 1. And for this reason, this one does not exist. Okay, in the next video, I'm going to do the ones that go to infinity. I think this video is getting a little long, so I'm not going to do this now, but yeah.